Hello, my name is Dan Savageau. I'm a transportation project designer for MoDOT in the St. Louis district. I'm here today to talk about the improvements we made to the 141-364 interchange. And this video presentation is for the Innovations Challenge. This is actually one of two videos that we are submitting for this innovations that we use at this project. And with that, I'm going to go ahead and share my screen and my presentation. So this presentation is for the CFA continuous fly auger tangent pile wall with soil nails. As I said, this is at the 141-364 interchange, which is west of I-270, south of I-70, and near Creve Coeur Lake in St. Louis County. The proposed improvements at 141-364 included constructing a displaced left turn for the movement from eastbound Missouri 364 to northbound 141. We looked at 14 alternatives, and this was the preferred alternative that we came up with. This allowed the south intersection for that left turn movement to northbound 141 to be pushed to the north side of the interchange and to occur at the same time as the westbound Missouri 364 left turn movement to southbound 141. As part of this job, we needed to construct a retaining wall between the western abutment of the bridge over 141 and the southbound lanes of 141. So here's a slide showing the location of the new displaced left turn lane. Here's another slide showing the same, the new lane as well. This is looking north for the southbound lanes of 141, just south of Page Avenue. So what were the challenges that we faced when designing this retaining wall? We had to construct the wall without damaging the existing Missouri 364 bridge. We had to work with limited vertical clearance overhead. We had to construct the wall in poor soil. Basically, 364 was the fill for the roadway built in the early 2000s was dredged from the Missouri River and capped with a clay layer. We also had to design the displaced left to provide adequate sight distance as vehicles are making that turn from the off-ramp to northbound 141. And this was considered, the wall was considered the biggest risk on the project, and we've had difficulties with similar type walls in the district. So how would we design and build this wall given all of these challenges? So we looked at four different options. Our consultant H&TB provided us with, like I said, four options, and we chose wall option 3, which was the preferred alternative. And this was the continuous fly auger CFA tangent pile wall with soil nails. The wall was originally designed with secant piles, but the contractor asked that we use tangent piles, and we allowed them to do so. So what is a CFA, continuous fly auger? Basically, it is a drill used to excavate a hole while concrete is injected through the hollow shaft under pressure as the auger is extracted. I have a video, I actually have a slide of that later on in the presentation. So what is the difference between tangent piles and secant piles? From the picture, basically secant piles have some overlap while tangent piles are right next to one another. Like I said, the project was originally designed using secant piles, but we allow the contractor to use tangent piles. Secant piles are harder, more difficult to construct. Thus, we did accept the tangent pile change. So why use secant tangent piles for the CFA portion of the wall? Basically, due to the sandy soil used for the fill on 364, we needed something to shore up the soil before we actually started constructing the wall so that it would not damage the western abutment. So why use what are soil nails and why use them? So soil nails are grouted steel rods, and in conjunction with the tangent piles were used to hold back the fill of the bridge. Soil nails increase lateral support and can reduce the height and embedment of the tangent piles. Within the tangent piles, we did not use any reinforcement. So due to this, the soil nails become the main structural element holding back the backfill under the bridge. So once the soil nails are installed, they are anchored in place, grounded in place, and then a steel mesh is placed and shotcreted is placed over them. So this slide just shows the profile of the wall, kind of gives what we were trying to do underneath the bridge of 364. Here's a typical section of the new wall. We have at the very top, you have the concrete slope protection, the gutter system, and fencing. And then below that, you actually have the CFA tangent pile wall, the soil nails that are installed through the wall, and then in front of that, you have a cast in place or a precast panel. After that, you actually have your barrier wall and your pavement. Here's just another picture of that typical section. And as I mentioned before, we allowed the contractor to use tangent piles instead of secant piles. So during the design, after working with our wall consultant, we ended up modifying the profile and typical section of the displaced left. This reduced the risk of the wall, reduced the height of the wall, and we felt that this change allowed us to reduce the risk and give us a better opportunity to have a successful project. So in terms of construction staging, here's a couple slides on that. The first part of the construction of this wall is to excavate out a small portion of the wall, or a small portion of the existing concrete slope protection. Then the tangent piles are installed using the continuous flight auger. Stage 3, the existing concrete slope protection is removed and the new slope protection gutter and fencing are installed. Stage 4, the soil nails are driven through the continuous flight auger wall. And the thing about these tangent pile walls with these soil nails, instead of building the wall from the bottom up as typical, this type of wall is actually built from the top down. So you excavate a little bit of area, you build a portion of the wall, and then you continue. And I'll have a slide showing that in just a second. And then stage 5, after the CFA wall and soil nails have been installed, you have a cast in place or precast panels have been installed, and then you can actually build the pavement of the displaced left turn ramp. So what is the project timeline? Project was awarded in July 2020. Construction began at the end of 2020, and then we opened up the left turn ramp at the end of October 2021. Project was awarded to Millstone Weber for nearly $5 million, and the subcontractor for the wall was Burkle and Company Contractors. So I'm not going to play this video, but here's a picture of the continuous fly auger drill. Basically, the drill is removing the sand and replacing it with the concrete grout for the tangent piles. So here's a picture of after the tangent piles have been installed, the first lift of the soil nails have been installed as well, and the shotcrete is in place. As you can see from this picture, as I mentioned before, we are building this wall from the top down. So we started at the ground level, which is near the concrete slope protection in the upper right. We worked our way down, installed the first lift of the soil nails, and then that second lift, before we install the barrier and the pavement, that is now ready to be shotcreted. Here's a picture of the installation of the soil nails through the continuous flat auger wall. For this slide, it shows the precast wall panels, which are being installed in front of the completed soil nail wall. This is just before the opening of the displaced left. You have the wall complete on the left. You have the 364 bridge over 141. You also have the barrier with the green flare, the green glare screens separating the displaced left and the southbound lanes of 141. Here's another picture showing the completed wall under the bridge. And then finally, here is the pedestrian bridge south of the Page Bridge, overlooking all of our improvements, which included changes or modifications to southbound 141, and then near the top of the screen is actually the displaced left and the retaining wall we built. So for this project, we certainly had a lot of challenges, and the result was that we came up with this innovation. We had some issues of whether we should actually do this wall or not, but it ended up being a very good project, and it seemed to work out very well. Thank you for your time.